Touchscreen. You can do that too. Okay, it's 7:30 and we're going to get started. It's 7:30 and we're going to get started. It's 7:30 and we're going to get started.
Can you believe I won't be on for about 10 minutes?
7:30 and we're going to get started. I know. Well, hold on. It's 7:30 and we're going to get started. How's that? All right. Let me get this started. Dr. Masood, I'm going to come to one of your classes and talk all the way through it. How about that? Okay. We're going to get started. Welcome to the September meeting of the Johnson Space Center Astronomical Society. I'm Doug Holland, president. Here I am. And we have kind of an unusual meeting tonight. We normally have our main speaker first, which is Dr. Aaron Clevenson over here. But Aaron's a good guy, and he has agreed to go in the second half of our meeting because we have a remote speaker, Paul Maley, which most of you know. And he's going to go first. He's actually coming in from Alaska, I believe. So we're going to let him go first, and we'll do our second half of our meeting first, and our first half of our meeting second. Don't let that confuse you. And we got about 10 million door prizes, and thank you to everybody who brought these wonderful door prizes tonight. So we're going to have some good ones. And we're going to be giving away that telescope over there, which we'll talk about. So you guys can bid on this. Chris, what? You want the telescope? All right. I collimated it, so it works. All right. So we're going to give that away tonight. So this is going to be an interesting and a good meeting, I hope. But before I get started here, I want to recognize Stan Lamb. Where's Stan? There's Stan. Stan contributed this picture to our opening slide here, North America and Pelican Nebula, that he shot, I'm guessing. Where'd you shoot that from, Stan? Where?
From home.
From home, Friendswood. So there you go. It can be done. Thank you, Stan. That is beautiful. Stan says he's only been doing this for about 18 months. You're making me sick. I don't like that.
As far as this, I've done a lot of planning during past years. Just got started in this.
You're just trying to make us feel a little better?
Mm-hmm.
Yeah. Okay. Uh-oh. Arrow keys to advance? This thing is not advancing. Stand by. We have Trevor's going to come in here and save the day. Unfortunately, we're going to have to go to that one. Okay, it's fine. Still not working, buddy. Oh, there it is. Okay, so it's the enter and then backspace to back up.
I was just using the arrow keys earlier.
Yeah, the backup is not working here. The enter key will advance it, but how do I back up? Is that going to be that's going forward again? Oh, that will back up. Okay, so I can do it that way. All right. Okay, fine. All right. Anyway, this is our agenda for this evening. First, we'd like to welcome anyone who this is your first time coming to one of our meetings. If it's first time, raise your hand. Tell us your name, how you found out about the Johnson Space Center Astronomical Society, and what your interest is in astronomy. Right there.
I'm a current NASA intern. I found it on a newsletter, and I wanted more information. It's my first time in Houston. So
Great.
I don't know a lot about what's going on.
So what's your name?
Rifa.
Rifa, R-I-F-A?
H.
Oh, okay. And you got a friend with you?
Yep.
Great. So you're just here because of her.
I'm also kind of interested in what exactly you're talking about today.
Great. Do you have a name?
Veronda.
Veranda. Okay. Excellent.
Where are you from?
I'm from New York City.
Where are you studying?
I just finished my master's in engineering management but my undergraduate degree is in mechanical engineering. I'm currently working in the system engineering department at NASA with the R5 CubeSat and the lunar water vehicle project at the moment. So that's my current project this semester.
So you're an ER?
Yes,
Yes?
EX.
EX?
Yes.
Okay, so you're an EX. Got it. All right, excellent. Anyone else? First time here? Or willing to admit that it's your first time here? Oh, there's somebody's first time here. Is this your first time here?
It is.
Excellent. What's your name? What brought you here?
My name is Braden Haldezos. I'm an intern over at NASA, but today was my last day.
Did you get fired?
No, I did not get fired. I'm just a summer intern, but my school starts really late, so I was the last summer intern.
Excellent. So you sit next to these guys, so I assume you know them.
Yes, I do.
Okay. You're all okay. You're doing good. You can up our membership. All right. Anyone else? First time here. Okay. Very good. So this is our agenda for this evening. I just told you in general what it's going to be. You can read it as well as I can. And first up, we are going to. Oh, let me tell you a couple of things. All right. So B, you see the clipboard? There's B. Thank you for being our door person today, B. If you'd like to get on our email distributions, B has a little clipboard there with some tear-offs on it. The one email address for David, the one that says Starhopper457, is for all the emails. The other one, Ron, is just for the meeting. So if you'd like to tear one of those off and send an email to those, and you can get on our email distribution, know what's going on, or you can take a picture of those, however you want to do it. If you want to know what's going on with the Astronomy Club, that is the way to do it. Speakers, when you come up here, oh, the little red pointer isn't working. Is that right? Okay, so let's see. That does not work, does it?
See if I can get it, 'cause
Okay.
the mouse was being real picky earlier.
It's not going to work. It's okay.
I brought a red laser that I will share with people if they want to use it.
That's the whole point, is you can't use the red laser. Okay, so speakers. So Aaron did perfect for me. He just told me what we're not supposed to do. Don't use a red laser pointer, but instead use this little mouse pointer here, because then the people online can actually see what you're pointing at. Yeah, see this. You'll just use the little pad here and move it around to point at things. It turns out we have pretty good attendance tonight, but we're actually getting between 50 and 200 people online between the meetings. So we want everybody to be able to see what you're pointing at. And the mic for the stream is actually in the laptop, and the mic for the room is this mic here. So you got to kind of stand over here in general for people that are here. You can't move all over the room, otherwise people on the stream can't hear what you're saying. Okay. All righty. So first up, we have Paul Maley with Excursions, Outreach, and this Transit of Venus, an adventure of astronomical proportions. This is going to be a remote presentation from Paul, who is in Alaska. So Paul, can you hear me?
Yes, I can. Can you hear me?
I can. Thank you. And we can all thank Trevor for making this work.
Okay. If you're ready for me to start, I'll go ahead and begin.
We are ready.
Okay. For those of you who don't know me, I've been a member of JSC for the last 55 years. And in 1970, I began organizing solar eclipse expeditions for JSC. And the next 2 weeks, we'll be traveling to Easter Island and Chile to observe an annular solar eclipse. And that'll be the 54th expedition related to eclipses that I've organized for the Society. I'm here in Alaska right now, leading the 27th Northern Lights expedition up here, every one of which has been successful, including this one. And I'm going to talk to you a little bit about a rather strange occurrence that led me to this presentation. Next slide, please. Okay, about 10 years ago, actually it was in October of 2014, I led a group to Churchill, Manitoba, Canada. And since leaving Houston, which was about 8 years ago, I moved to Phoenix, Arizona. And this graphic shows the path as to how you typically get to remote Churchill, Manitoba, which used to be a lot more interesting and frequent prior to the pandemic. But since that time, it's been a lot tougher to get here. So basically, you'll fly to Denver and then to Winnipeg, Manitoba. And then there's a tiny airline that flies like once or twice a week, and it costs $2,000 round trip just to get from Winnipeg up to Churchill and back nowadays, which is pretty ridiculous. But Churchill is well known for its polar bear population. And I led a group up there 10 years ago, and in the process of looking at polar bears, we eventually came back to Houston back then, and a guy sent me a photo, which I'll show you in a little bit, that led me to this particular initiative. Next slide, please. So in the last many hundreds of years, there's only been 7 transits of Venus, that is the passage of Venus in front of the sun, where astronomers on Earth could see it. In 1761, there was kind of a massive expedition conducted from various points around the world because it had been well predicted in the previous century, but not well observed. In fact, the first one was observed in 1639, and they figured in 1761 this would be pretty cool. So the idea was not just to go out and look at a transit of Venus, but to try to determine the scale of the solar system by measuring the exact distance between the sun and the Earth. And so that was their grand objective. And that has been carried out initially since the 1761 event. And in that particular year, most of the astronomers failed in terms of gathering enough data or in a proper format to be able to develop an accurate portrayal of what that distance was. But in 1769, there were a number of other expeditions. Roughly about 100 separate astronomers went out in different directions. You're probably most familiar with Captain Cook, and he went to Tahiti to observe, and there's all kinds of memorabilia creating, or rather commemorating what he did. But in fact, probably the more unimpressive expedition in terms of publicity was carried out by 2 Englishmen who went by ship from the UK across the Atlantic Ocean and up into Hudson Bay, Canada. And this was an event that sort of disappeared in the sense of how little people know about it. So this friend of mine sent me a picture, and he told me that there was a glass case with some relics from this Transit of Venus expedition. And so I started looking into it, and I got to thinking, wow, this is really great. But in the visitor center, which is located in a train station here in Churchill, Manitoba, has sort of sat there without any publicity or recognition. So I started to think about, well, maybe there ought to be a way to get a historic plaque developed for this, much as I had done for 2 other Transit of Venus expeditions conducted in 1882, one by the U.S. Naval Observatory in San Antonio at Fort Sam Houston, and the other just outside Fort Sam Houston, conducted by Belgian astronomers. And both of those expeditions were successful. Again, that's 1882, so you can see that's number 5 on the list here. So next slide, please. So back in the day, in the 18th century, Napoleon and William Pitt, representing France and the UK, were busy carving up the world and essentially sending out scientific expeditions to do this and that. And it was pretty challenging to do this, given that there was wars going on at different times. And it was difficult for astronomers to navigate successfully and to be allowed to conduct expeditions into foreign lands. Next slide, please. So this particular slide kind of gives you an idea how dangerous it might be by a current article that appeared some time ago, and I figured I would bring this up because of someone who had done a statistical study on the risk of going to solar eclipses essentially during the day of the eclipse and what's the likelihood of being killed in a car wreck. And so someone came up with this particular data that indicated that roughly every 95 minutes there might be a vehicle crash associated with people headed down the road toward any particular solar eclipse. Next slide, please. So these are this chart shows you all the expeditions that I've done over the years to different locations in order to see specific solar eclipses, as well as 2 transits of Venus. The 2 transits of Venus expeditions are in yellow. The rest of them are sort of in orange. And back in the day, in the 18th century, if one had conducted even one of these expeditions, chances are it would have taken them many, many weeks and months to actually go from their point of origin to the location and then get back. And in a number of cases, astronomers were not very lucky in terms of living through the experience. Next slide, please. So here it is. The overall goal was to determine the astronomical unit, AU, which is also an abbreviation for the African Union, and gold, and several other things that might confuse people. But fundamentally, it was the main goal of astronomy during the 18th century to determine this distance, and most institutions would do almost anything to get someone in a position to make this observation and attempt to be the first to narrow down what that distance was. Next slide, please. So here it is. This is a table of distances from the sun of each of the planets described in terms of AU. So you can see that Mercury is roughly half the distance between the sun and the Earth. Venus about 2/3 of the way to the Earth, and the Earth itself going all the way out to Pluto, which is 35 astronomical units distance from the sun. Next slide, please. So back then, ships were the primary mode of transportation, and on ships were barrels, and barrels were loaded down with all kinds of stuff, and usually there were stuff that male astronomers wanted to drink, because there was no such thing as a female astronomer back in the time of this observation. So what they did was, in addition to getting fairly drunk most of the time, they would use these barrels as a prop for their telescopes. They didn't have equatorial mounts or fancy motor-driven mounts. They had barrels. And so if you didn't have a barrel, you really weren't doing very much. It's hard to hold up one of those clumsy refractors and point it to something for any more than a few seconds without getting a little bit dizzy and falling over. Next slide, please. So this was the photograph that was sent to me on the right, along with a little bit of a description. And it was that kind of fascinated me, realizing that there was nothing in the visitor center that made this particular relic important. So after going through a lot of research, attempting to look up historical articles and things, I found a number of documents that described this expedition, and I knew I had to get on the stick and do something to try to get the expedition the recognition it deserved. Next slide, please. So this is an example of transits and what astronomers want to use them for. On the left, you see a transit of Mercury that I was able to record in 2019. You can see that tiny little dot, totally useless, extremely difficult to measure with precision. And there you see the big blob. I say big because it's big as far as any object passing in front of the sun. And that's the transit of Venus, measured by myself with a small telescope from Mauritius back in 2004. Next slide, please. So this is another example of the transit of Venus from my next expedition in 2012 in Turkmenistan. Here the Venus is far more clear because it was a much higher altitude. You can see it compared to sunspots that were also on the surface, which are much more diffuse. And so it's pretty easy to spot Venus compared to that. Next slide, please. And here is Venus again during that same transit in 2012, silhouetted against the edge of the sun. And this is pretty important because part of the problem in making observations back then and even now is the fact of determining the contact times between the edge of Venus and the edge of the solar limb. And that enables a more precise measurement of not only the diameter of Venus, but to determine the atmosphere and how its thickness relates to the observations that are being made for it. Go ahead for the next slide, please. So here's an example of the kind of groups that they had observing various transits. The 1874 expedition is all male, and you can see on the right one group in South Africa, and the rather bizarre, ancient, and crude instrumentation that was set up on the Chatham Islands, which I visited a few years ago from Australia. Next slide, please. So this is the historical plaque that I had proposed to the Monuments Board of Canada in 2014. And last year they approved this particular plaque and the text that goes with it after a lot of back and forth. Unfortunately, the Canadians seem to relish the fact that the Hudson's Bay Company, which sponsored the English expedition over there, was more important than the science itself. And when they sent me the first draft of this, it didn't even mention the transit of Venus. It mentioned the fact that this was the location of the first science that was ever done in Canada, which again was extremely important, but it only mentions the Hudson Bay Company. So that's why back and forth text revisions went for almost 10 years, from 2014 up till now, until it ended up with this being the final portion of it. And regrettably, the JSCAS is not mentioned, but then, you know, it's better to get something than to get nothing. Next slide, please. So in 1769, William Wales, whose portrait is here on the left, was a relatively unknown astronomer who was hired to do this task. And his main condition was that he'd be willing to go to Canada as long as it was warm and not too far out of the way. So what they did was they sent him in the summertime. Temperatures were in the 60s. And then by the time he figured out he had sort of been duped, he ended up in Manitoba where the temperatures went down to minus 40. He wasn't real happy about that. But he had no choice because they sent him a year before and they wouldn't bring the ship back until after the transit, a little over a year and a half later. Next slide, please. So unfortunately for everybody in the room who's never seen a transit of Venus, the next one is not until 2117. And so you have a long wait if you're going to do that. And you can see that the best area for seeing the entire transit is going to be in Southeast Asia, with just a small portion of it in the western part of the United States. Next slide, please. In 2125, which is 8 years later, the best part of the transit will be visible in the eastern and central United States, essentially the entire transit itself, with parts of the transit being visible in other parts of the world. Next slide, please. So to go to Churchill and to make this plaque dedication, one of the things that I have to be concerned with is bears, polar bears. And they have signs everywhere in Churchill warning people against walking around and doing things, much less at night, but certainly during the day. And several people have been attacked since the recorded instances of tourists being approached by polar bears. And so they put up all of these signs to keep me and other people from doing something really stupid. Next slide, please. So this is a diagram showing Hudson's Bay, that blue area up to the north. Churchill itself is on that little peninsula going out. You can see it's a very small place. Population is roughly 900 people, and the number of polar bears in the area is estimated to be 3,000. As it turns out, that the location for the transit of Venus observation was called Prince of Wales Fort, which is that other peninsula on the left side, and it's pretty distant from the main town. But then Churchill didn't exist in 1769. This is a view as of today from a satellite. Next slide, please. This is an overview of what the fort looks like, a typical British square type design. The transit of Venus observations were made from the southeast abutment, which is, you can see the lower right quadrant, and very little defense against the wind. which down there blows almost consistently. In fact, even when I was there, it was blowing every day. 30 miles an hour was not uncommon. Next slide, please. So we had a ceremony that was organized by the Monuments Board, including a representative from the local Cree population, which blessed each person with incense. And we had to go through that. It took about 20 minutes because there were quite a number of people there. Next slide, please. And this is the actual plaque presentation. This is a replica of the plaque, which is currently hanging in the visitor center. And what they did is they told me they were going to give me this replica to take back to Arizona. And that was a real challenge because I ended up buying all the packing material, tape, and that I could possibly find in order to get it packed for the flight back to Phoenix. Next slide, please. So, not to be unchallenged by polar bears, I decided I was going to go out at night. And one of the things you don't do is go out at night. And I learned this the hard way by the fact that when I went out there, I only had to walk 4 blocks until I came up to Hudson's Bay. And part of the problem was I never saw anybody, not a human being, not a dog barking, not a vehicle. So that led me to think that maybe these signs had some merit. But once I saw the northern lights, I couldn't help myself. So I walked out the 4 blocks, looking to the right, looking to the left, everywhere, to be sure that I was going to be jumped by a gang of polar bears. Next slide, please. So here you can see that the lights were changing pretty dramatically, very intense. You can also see a full moon in the right side of the photo, and the ground is lit up there because there are lights everywhere. So it makes photography a real challenge because they have to have illumination in order so people can see polar bears if they're out and about. Next slide, please. So I spent 3 or 4 hours out here. This is another example of the lights as they changed, and I was right there on the edge of the bay where waves kept rolling in. And again, I kept looking to my right and to my left, but the camera was not impressed, and it did take pictures, and they all were in focus, believe it or not. Next slide, please. There is a type of stone monument called a nukshuk, which is a local way of providing directions and also food when people are wandering around in Manitoba and they get lost. And so they have several of them erected out here on the coast, along with some park benches right there on the beach. And so I set up in front of one of them mainly as a photo foreground. Next slide, please. The lights kept changing, and you can see the Big Dipper off to the left, Cassiopeia up on top, and the skies were really great that particular night. Next slide. Okay, so this is the last slide, and it basically shows the commemorative plaque process having taken 10 years, when it's estimated that travel from Earth to Mars will be about 9 months. To build a stamp from scratch and have it approved by the post office takes 3 years. And if you're going to try to become an Austrian citizen, that takes about 10 years. So this gives you sort of a scale of comparison between the project that I undertook until it was finally completed and some other things. So that is all I have, and I thank you very much.
Thank you. All right. Do we have any questions for Paul? Okay, Mark?
I noticed on the slide with the list of the distance of the planets from the sun in astronomical units, you had the Earth as 1.02 astronomical units from the sun. Where does that 0.02 come from?
Were you able to hear that, Paul?
No, I wasn't.
Okay, so Mark is asking, why was your astronomical units from the sun to the Earth 1.02 instead of 1?
I actually don't know the answer. I didn't prepare that chart. It was something that I pulled off a reference. And I noticed that too. It wasn't It should have been much more even than that. The point of this particular expedition was that once the data was reduced by the Royal Society, it turns out that the end product was within 0.08% of modern day values of the real astronomical unit. So that may help somewhat explain, what that difference is.
Okay, any other questions for Paul? Yes. Okay, the question is, what's happening in this picture that we're looking at?
Oh, probably an astronomer who didn't predict things accurately.
I was gonna say
That's why the JSCAS exists.
Yes. Astronomy is a very dangerous business.
Yes, it is.
Yes.
So up here in Alaska, we had one fantastic night. 2 nights ago, we encountered a geomagnetic storm. And as I mentioned to someone there that I took a total of 383 photographs until I got so tired I couldn't do anything. It was that exhausting. And tonight we may have another shot, but it's been cloudy here as it typically is during this time of the year. But it was a truly exciting night. And if anybody is interested in watching the Northern Lights from up here versus down in Texas, I totally recommend it.
Okay, any other questions for Paul? Okay, Paul, I have one. Did you ever see a polar bear while you were there?
Absolutely not. In fact, they have a polar bear jail here. It's located right next to the airport. It looks like it's a big airplane hangar. And they told me that there were no bears in the jail this year, which is rather unusual. And one of the reasons that I walked out there was that the taxi driver, who, by the way, doesn't accept credit cards, was telling me that he walks around town at night this year because last year they had polar bear intrusions every night, and it was a really dangerous time. But this year, for some reason, the polar bears have steered clear of Churchill. So I decided to take his advice, and it turned out to be very accurate.
Okay. Any other questions? All right, let's give Paul a round of applause. So, Paul, thank you very much for going through all the effort of bringing us that presentation all the way from Alaska. That was unusual and great. So,
Okay, thank you.
thank you. Next up, we have David with Star Party News.
I'm going to do a shameless plug for eclipse tours. I've been on 2 of Paul's total eclipse tours and 1 Aurora tours. Top-notch operation with top-notch trips is really a lot of fun. So I would encourage it. All right.
Hit the enter button to go forward.
Enter. Oh, enter.
Enter.
Okay. Schedule is right here. Past events, Friday, the last month, August 16th, we were at the Hack Winery. Boom, tomorrow night, Hack Winery. We've also got a conjoined effort with the LPI and UH. I just dropped a name. I got one. Forget where'd you go? The cellist, yeah. Mark, yes. He's gonna try to make that event here. Connie and I will be at Hack tomorrow. September 27th to October 5th, Okie-Tex. Hack again on the 4th of October. Observe the Moon Night at the George. It's not the international one, but usually first quarter moon. They're going to try to do that event there. That's in lieu of the old A-Day. 25th and 28th trip. It's not tentative. I need to make that as confirmed. Sorry about that. The confirmed trip to Fort McCavitt. 28th to November 2nd is El Dorado. Friday, November 1st, we're back to Hack. And then on the 9th, we've got Evelyn Meadow. That was a very popular one. That is a library that's out in Seabrook. I have a star party there from 7:30 to basically until it spins out, usually about 10 o'clock. I've manned up with Magnolia Creek Golf Course asking for the same date. I'm going to have to probably try to shove them off a week. We won't have the moon in play, but we'll figure something out. This will definitely won't be within daylight savings time. November 12th here, around back over there, UH Clear Lake with the Physics and Astronomy Club with the physics professor and Brandon. And on November 14th, Armin Bayou, of all places, has asked us for an event. That's a Thursday. There at the Nature Center, we'll get more details on where to go. November 12th and 14th, I might need somebody, Leslie or Chris, possibly to take point on that because I may not be in the country during that week. All right, the event for tomorrow night, we're tucked around right here, is directly in back of us. That parking lot out there is where it's going to be for tomorrow night for those that decide to come here.
Wait a minute, it's in the parking lot?
As I understand it, by the circle, yeah.
What's that star for?
Well, where is that? Is that, if that's out here, that's fine too. But
Star party by the star.
okay, never mind. Star party's there. We parked there. Okay, got it flipped. Saved at the last minute. So you're on the grassy knoll. Okay. All right. From the 16th, I thank Chris Randall very much for these pictures. Chris Randall, Bob and Leslie Eaton, Reed Klotzler, and I believe that's Kevin and Karen Beard. Upwards of 200 in attendance. This looked like a really good populated event. I was north of here and wasn't able to make this one, but it looked like to be a pretty good fun event. And hopefully we'll have something tomorrow night, although I'm not sure about the clouds. The weather might be okay, but won't have a lot in the way of precipitation, but we may have some issues with the clouds. And hopefully Lady Luna will be able to poke their way through. There's Bob Eaton and Reed over here. And then for those of you, your new telescope is out for delivery. If you ever make it to the George, FBAC succeeded in a massive fundraising event. They now have a brand new astrophysics mount with a CK-17 plane wave in the East Dome that saw first light last Saturday. So they're the reason where we've had 2.5 weeks of clouds, because they've $50,000 and you're going to get 2 weeks of clouds. So it was supposed to take 5 years. It took about 4 months. The George Foundation and another foundation was more than happy to drop the cash. So the old 18-inch reflector spontaneously, what do they call that? RUD? Unscheduled, rapid unscheduled disassembly. It started coming apart the minute they started trying to take it off the mount. So they were able to sell the mirror, the primary and the secondary, and the focusers, but the OTA itself pretty much self-destructed as it was coming out, and they've got it completely replaced. So,
All
right. Yeah.
So David, at Fort McCaffrey this year, there's quite a number of people that are going that have never gone before. So do we know anything about how it's all going to work this time? You know, we're going to do the group dinner on Friday night. Do we?
Oh, you mean the subtle hint that I should probably put up the primer tomorrow morning on the website?
I think what it is, I think we need to find out, like, can we do RVs this time? Can we sleep in the buildings? You know, we need to figure out how Fort McCaffrey works.
As I understand it, it's always been, has it changed? I know the RVs have been moved back, but I don't know if it's changed periodically.
I don't want to assume anything, but do you think it's exactly the same as it's been in the past?
I haven't heard anything from Ken or Lisa about the operation of the fort thing changing. We could send them a quick email and say, are we still good? Because I know Lisa used to coordinate people staying in the barracks. And then Ken would assign RV slots and people could tent off to the side.
Okay, well, I would say if you're willing, next month, we probably ought to do your presentation on Fort McCaffrey, because there's quite a number of people that are going that never gone.
I could do a cut down version of that for next month.
Okay, all right.
We'll do that, and I'll throw the primer up and I'll check it out with Ken.
Yeah, okay.
All right.
All right, thank you for being our Star Party chairman. That's a lot of stuff. Okay, Ron, you want to tell us about DVD library?
Yeah, we've got about 200 titles, and the ones on the left up there on the screen, those are the great courses. They're 10 hours plus, sometimes 14 and 16 hours. The ones on the right, the vast majority of the titles are the ones on the right, and they're 45 minutes. They're made by Astronomy magazine called Infinite Cosmos. We also have Chinospheres, Pocket Atlas,
Well, she wanna go.
And
She wanna
if
go.
you don't have a DVD player anymore, you actually have some local to you, so just plug it into your computer, so anyway. And if you've made several meetings, you're free to take them out. Thank you.
Great. So during the break, you guys can go over to see Ron at the DVD library and check out a free DVD. Take it home and watch it. He's got a lot of really great titles. I've got one right now about the Chandra X-ray telescope. So we need to use the DVD library or it's going to go away. So get yourself a DVD at the break. All right. Now, if you've been coming to these meetings, every once in a while we give away stuff. So we are going to give away that telescope over there tonight. Okay, so here's some information about it. It's basically a 6-inch Dob. It comes with a couple eyepieces, a couple plus eyepieces, a 25 millimeter, 9 millimeter. It's got a moon filter. It's got a finder scope. I collimated it. It's probably one of the better of the telescopes that we have given away. So if you guys want this, everyone's welcome. Anyone here tonight can win this telescope. Here's how it works. You go over there and there's these little pieces of paper in front of it, one ticket per person. And at the end of the meeting, we're going to have a drawing for it. And you must be willing to carry that thing out of here because the reason my shirt is all sweated out is because I carried it in here and I don't want to take it home with me. So, and I got all this other stuff. So anyway, you got to take it out of here. That's the deal. And like I said, I've collimated. So there's these little pieces of paper in front of the telescope. You pick up one at the end and we're going to do a drawing for it. Anybody who's here tonight is eligible to win that telescope or take it home. Win. It's a drawing. Yeah, it's free telescope, right? Okay, after the meeting, we're going to get together at Mod Pizza. You guys up there, you guys are all welcome to come to this. The Mod Pizza that's right up in front of HEB. You guys know where that is? You guys are from out of town, right? You're from New York? Anyway, you are. Okay, yeah, you zip up Middlebrook. You take a left on El Dorado. It's at the corner of El Dorado and Clear Lake City Boulevard. Right in front of that big HEB, there's a Mod Pizza. And we get together there and we talk about astronomy and all of the kinds of things. It's a lot of fun. So everybody here is welcome to come after the meeting. And our main speaker is welcome to come too, if he wants to.
Works for me.
Yeah, if you're willing to eat pizza in the middle of the night and make yourself sick. All right, so we're going to take a short break, about 10 minutes. Let's see, how much time we got? Hold on, I see a hand. I got your hand. Hold on a minute. Let me think for a minute. We got a lot of stuff to do at the break. I think we're going to take a 15-minute break tonight. Okay, 15-minute break. Hold on, Rodney. DVD library, come get your ticket for this thing. And you guys, listen, you can talk to everybody during the break, but when it's time to start the meeting, shut up and sit down, okay? So we can start the meeting because it's really irritating to have to wait and wait and wait for you guys to stop talking so we can start the next part of the meeting. All right, what, Rodney?
I've been looking since April for the T Coronae Borealis thermonuclear explosion nova to arrive. And so Corona Borealis out tonight. So if I see it or anyone, is it going to be alerted on the website or something? Because I can't look every night, but.
Oh, it'll be announced broadly. It'll be hard to miss the announcement. What? But yeah, I've been waiting too.
It'll get the email airwaves, so.
Okay.
If anybody knows, put it down on the distribution. Okay, starting now, we're going to have a 15-minute break. Thank you.
There.
Can I get one? Yeah.
Okay, we're going to get started with the second half of our meeting. We're going to get started with the second half of our meeting. We're going to get started with the second half of our meeting. Hey, it worked this time. This is from Kenya. It's called a rungu. Some guy at church gave me this and said, when the chief comes out and he does this, everyone is quiet. Or otherwise they get hit. Boom, boom, boom. See? All right. So, all righty. Okay, the moment you've been waiting for, our main speaker, Dr. Aaron Clevenson. Let me tell you a little bit about Aaron before he comes up here. Dr. Aaron Clevenson, that guy right there, has been an astronomer for 45 years. I know he doesn't look that old, but it's true. His goal in astronomy is to see it all. Although he has made great progress towards meeting this goal, he does not feel that he is any closer. It seems to keep moving. Aaron is currently the director of the Insperity Observatory in Humble, Texas. And by the way, if you've never been to the Insperity Observatory, it is quite an accomplishment. You guys have public nights when?
First Friday of every month. So it's not on the night of your meeting. You all can come.
Yeah, it is really something. You guys should go up there and see this place. These guys really have something to be proud of. Okay, also the treasurer and past president for North Houston Astronomy Club, NHAC. He is the league secretary for the Astronomical League and one of the observing program directors. Aaron is a member of the Space Oddities Live panel and can be seen in a weekly YouTube broadcast. He is also a retired professor from the Lone Star College where he served for 18 years.
Teaching astronomy.
Teaching astronomy. Sorry. Yes. Okay. His presentation tonight is the result of his recent trip south of the equator and will focus on southern sky observing as well as recent aurora in May. Join me in welcoming Dr. Aaron Clevenson.
Okay, so where's the enter button? So it's just on the keyboard?
Yeah, on keyboard, enter goes forward, and if you got to back up, let me know.
Does that key work also?
This is the only one I know will work.
Well, we'll try this one. If it doesn't work, we'll try the other one.
You may blow the whole thing up.
It worked. Okay. This is going to be tough because I need my glasses to see the computer, but I don't need them to see all of you. So hi, good to see you all again. It's been a while since I was here. Actually, I've never been here before, but been to a JSC meeting. So it is good to see you all. I do recognize a bunch of faces from previous times. And thank you for inviting me back. The powers that be. Wonderful. So this is, in a large way, kind of like a travel log. And I'm not going to do all the sightseeing stuff that we saw because there was a lot of sightseeing on this trip as well. But I want to focus on astronomy-related stuff. And my one goal, major goal in this presentation is to inspire all of you to go south of the equator. You need to do it. If you're into astronomy, what we see here is great. And of course, being at 30 degrees north, we get to see quite a bit, but it's not all of it. And some of the absolutely awesome-most, is that a word? Awesome-most astronomical objects to see are southern hemisphere. So you do need to go down there to see them. Okay, so let's take a look at this. So why am I doing this? Well, many of us have never had the opportunity to go south. I was one of those people. I had been further south than here, but I had never been all the way down where I could actually see some of these things. So it was a wonderful thing. It was recent. It was in May. It was a family trip. The family decided they wanted to go, and I said, oh, okay, as long as I get to do astronomy on the way. And like I said, I want you to get out there and do it yourself. And the second half of this presentation is about the aurora. So we'll talk about that when we get there. All right, so the first part, southern skies. And what's the big deal? Yeah, northern skies, southern skies. If you understand the concept that the entire universe is homogeneous, that it's all the same everywhere, then we got stuff here, they got stuff there. What's the big deal? Well, the problem is, and some of you, many of you perhaps know all of this already, but I'll go through it anyway. So as we rotate through the night, the Earth's rotating, the sky seems to move, and as it moves, we get to see a new degree of sky, or not a degree, but a new section of sky, a new hour, about every 15 degrees. I said that wrong. Every hour we get to see about 15 degrees more of the sky. Let's say it that way. But some of it we can't see because of daylight. Yeah, we all know that, right? You know, we miss stuff during the day, but that's okay. So we get about a third of the sky we can't see because of that. And of course, it varies from season to season because in the wintertime we have a lot longer nights, so you get to see a lot more, and during the summer they're much shorter. Also, as the sun orbits as I did that twice, as the Earth orbits the sun, we get to see different parts of the sky at the same time of night. So let's think 9 o'clock tonight, it's pretty much dark, 9 o'clock every night, all year long. So 9 o'clock tonight, we see stuff that's much different than we'll see 6 months from now at 9 o'clock at night. Because if you think about it, we're on the opposite side of the sun, which means the stuff we see at night, always pointing away from the sun, is going to be in the opposite part of the sky. So we get to see stuff we don't normally see. However, we're also limited by our latitude. So if you think about it, we're at 30 degrees more or less north, and that means you can see down to 60 degrees south. Not exactly, but close enough. So, all right, 60 degrees south all the way up to the north celestial pole, that's quite a bit of sky, but there's that piece at the bottom that we're missing. And so the reason for going south is to see that part of the sky. All right, so I got a little bit more. I'm a visual astronomer. I believe that nothing replaces actually looking through an eyepiece and seeing stuff with your eye. Yeah, it's not as impressive as what you see in magazines or on the internet or with your camera if you're an astrophotographer. Yeah, those are really, really cool, but you're not seeing it personally. And so to me, that's an important thing. That's why I'm a visual astronomer. And I really think it's important to do that. So you can't do that with a robotic telescope. So yes, if you have money, you can rent time on a robotic telescope in the Southern Hemisphere, and you can get images of all these wonderful things that we can't see here, but it's not the same as seeing it with your own eyes. I also mentioned, don't forget to do sightseeing while you're down there because there's all kinds of cool stuff to see. And the second part of this talk, you might be able to catch the aurora australis. So borealis is north, australis is south. So this was the southern aurora. And I was impressed. I had never seen an aurora before. So, hey, this is really cool. Okay, keep going though. So I live in Houston, and I'm going to use Houston as the example. Houston's roughly 30 degrees north. I'm not going to read all this. And the reason I'm not going to read all this is sort of what I just said. But if you want to take it to the extremes, if you're at the North Pole, Polaris, the North Star, would be directly overhead, more or less. And if it's directly overhead, that means all around the horizon, and you can see all the way around the horizon, it's the celestial equator. It's basically our equator taken out into space. Well, that's great, but that's also only the northern hemisphere of the sky. So you're missing the whole other half of that sky. Same thing's true if you went south. Okay, so what do we want to do? Well, let's take a look at it. So these are the limitations, and let's see if I can use the mouse. Oh, that's wonderful. Okay, so got to get up here where I can see. Okay, so this red line through the middle is the axis of the Earth that we spin on. And of course, it's not straight up and down in the sense of our orbit around the sun. It's off to a little bit of an angle, 23 or so degrees. Okay, so not a problem. And if you think about what else we have, this is the latitude of Houston, which, you know, it's 30 degrees north, so it's a little bit above the equator. The equator is the red line through the middle down below that. And our visibility limit, as far south as we can see, was -60, which is this blue line down here. Now, I said there's a piece of the sky we can't see. And if you look at this picture of the Earth, that looks like a pretty small piece. And it is, compared to what we can see, but some of the coolest stuff is down there. So it's really important to get the opportunity to go see this. Looking at another way, now I've taken the Earth out of the picture here and put the sky in instead. And what you can see is down here on the southern end, sure enough, there's not a lot of them, but there are some constellations down there. And as I mentioned, there's a bunch of deep space objects in those constellations. So exact same map, it's just a little bit different because now we're looking at the sky instead of the Earth, which we're not looking at the Earth, right? We're looking at the sky. Okay, so what kind of things can we see? What's missing? Well, I think these are probably the three big ones. The top one up here is the Coalsack Nebula. It's a dark nebula, so it's a dark dust and gas cloud. It's so dense that you can't see many stars shining through it. And it is rather profound. It's right next to the Southern Cross. I was amazed how close it was. You know, living up here, I can't see either, so I don't think about that. But when I got down there, I said, Southern Cross. And right next to it was the Coalsack. Really impressive. The only thing I was disappointed from, and living in Houston, we probably can all relate to this, was when I wasn't in a really, really dark location, it wasn't really impressive. It's like everything else. It gets washed out by light pollution. So most of our stops along the way were in cities. I wanted to do astronomy, and we would stay at a hotel. I would go outside to the little park next door or across the street, set up my telescope and observe, and just way too much light pollution. The big one below that is the Large Magellanic Cloud, and the one off to its left here is the Small Magellanic Cloud. And they were pretty cool. Those are two of our most closest galaxy neighbors. They're satellite galaxies around the Milky Way, our galaxy, and they're rather irregular. They're not very exciting from an aesthetics standpoint. They're not beautiful spirals or absolutely beautiful ovals or anything like that. They're just kind of blobs, but they're there, they're visible, and pretty cool. So I think those are the three main draws, but then there's a whole bunch of other stuff as well. So another one, I mentioned the Southern Cross. I offer a challenge to all of you. That's oriented funny, but we'll roll with that. I got a point. All right. So this star over here is the northernmost star, if I have it right side up, and I think I do. And that star is visible from Houston. It's only a few degrees above the horizon. I saw it from the NHAC dark site many, many, many years ago, so it was a previous dark site. But it is visible. You can see that. In fact, when I got thinking about it, this was way back then, I said, I want to see more. And I got my charts out, and my charts say if I went down to High Island, so I was on the coast, right there on the Gulf, I should be able to see the two cross stars. That's, this one up here and this one down here, 1 degree above the horizon. And I did. So from Houston, I count that as Houston. So from Houston, I had seen the top 3 stars of the Southern Cross. I thought that was really cool, but I didn't get the 4th one. And, there's a line by Crosby, Stills, and Nash that says, when you see the Southern Cross for the first time, you know why it is you came this way. I think I got it close. And that was what the rest of my family kept chanting on this trip. And I said, well, okay, I'll point it out to you as soon as we can see it. And sure enough, the first night we were there, we could see it. And but I maintain the second part of that's not true. And they misunderstood what I was actually trying to say. You all, being astronomers, will appreciate it. Until you see it from dark skies, you haven't seen it for the first time. So I had seen most of it from here. We saw it on the northern island in New Zealand. And sure enough, it was there. It looks just like that, except it was faint and washed out because of the light pollution. So anyway, they did not appreciate my sentiment, but I still maintain that's true. You got to go somewhere dark to see it. Okay, so a little bit more. What else are we missing? So I know that Johnson Space Center is not part of or Johnson Space Center Astronomical Society is not part of the Astronomical League. So I'm going to talk a little bit about the Astronomical League. As was mentioned, I'm very heavily involved with them. I do have some things that you guys can do. And if you happen to be members of one of the other clubs in Houston, then you are members of the Astronomical League. So you would have access to all of this. But one of my goals on this trip was I've done a lot of the observing programs. Right now, we have over 65 observing programs with the league. And I have probably done, or had probably done 60 of them. Numbers aren't quite right, but close enough. And it's because I'd never gone south. There's a whole bunch of southern ones. So I said, I'm going south. I'm going to do this. So on this trip, I went with a list of 259 objects that I wanted to observe. Some were naked eye, some binocular, and then, of course, a bunch were telescopic. And I will just report right here, out of those 259, I managed to observe 250 of them in 2 weeks. Yes, my family did not see much of me when I was down there. And I'm pretty confident I slept through most of the tours we went on. And the 9 I didn't get, I can get from the observatory up in Humble, the Insperity Observatory. So I don't feel bad about that. I intentionally left the 9 northernmost ones till the end. I said, I can get these later, which I will. So again, not that it's a big deal, but Southern Skies Binocular, it's a list of, if I remember correctly, 50 objects that you're supposed to go see out there. Don't quote me on the numbers. Southern Sky Telescope, I believe, is about 70 objects. There's a little bit of overlap in some of these. We have a new one. It's called the Bennett, and you can think of it as the Messiers for Southern Sky Observers. Bennett was a guy in, I think, South Africa, an astronomer, who said, it's not fair. I want to look at something, and we don't have a list. So he came up with a list, and it's a pretty cool list. That's where the 7 I'm missing are, actually. Constellation Hunter, I'm proud of this one because I actually created that for the Astronomical League. There are 2, northern and southern, and I was embarrassed that I created this, but I've never done the southern ones because I couldn't get that last 30 degrees. So that was one of my goals. And Caldwell. So just like we have a Messier list, there is also a Caldwell list, for anyone who doesn't know, 109 objects, and they are the 109 that Caldwell maintained, Messier missed. Okay, good objects. They're not as impressive as the Messiers. I do have to say that. But to get gold, about 30 of them you have to be in the southern hemisphere to see. You can't see them from here. So I said, all right, we've got to do that. And just while I'm at it, we also have something called the Banbury 600. This is an Australian guy. I think he's from Australia. And he, same kind of thing, you know, it's the equivalent of the Herschel, but Herschel 400, but this is the Banbury 600. I haven't done that one. Don't plan to do that one, because that would just take an incredible amount of time. But for anyone who goes down there, spends some time there, and you're really enthusiastic, there's another whole list out there. Okay, anyway, so where are we going to go? We want to go to the southern hemisphere. I told you, you've got to go. You want to go as far south as you can go, within reason. I mean, Antarctica would be fun, but kind of cold and an awful long ways to go and probably extremely expensive. So what are you going to do instead? So it's we want to go as far south as we can. We want to pick a date when we have longer nights, because that means you have more observing time. But if you go far enough south, it's like going farther enough north, it gets really, really cold. The night we were in the observatory, that I'm getting ahead of myself, but the night we were in the observatory, it was 32 degrees Fahrenheit in the observatory. And it was cold. It was so cold, the astronomer and I both, I had signed up for a couple extra hours. I said, I want to use your telescope. I understand you need to be here to keep an eye on the equipment, but I have to drive. And they agreed to all that for some ridiculous amount of money. But he and I both agreed it's way too cold. We're not going to do that tonight. So we did what we were there for, but that was it. Okay. Anyway, and you want to pick a destination where you can get the darkest skies possible. So Sydney, Australia would not be a good choice. But from Sydney, you can drive out into the desert and get away from the city, and you can actually see the night sky. So that's the first set of things that I think about traveling. The next one is, well, where do you go? So here's a few. New Zealand or Australia. And if you look at it, except for going very, very far south in South America, New Zealand is about as far south as you can go. Australia, of course, is great. Australia is the size of the US, so there's a lot of land there. A lot of it is virtually uninhabited. So, you know, a lot of places you can find dark skies. South Africa is a good choice because it's far enough down there. And then sort of your last option is South America. And there are some advantages to that, right? You can go see the Atacama Array radio telescopes and other things while you're there. So there's some really, really cool stuff that you can see there as well. So those are kind of your choices. The one we chose happened to be New Zealand. I'll tell you a very quick story of why. So the whole trip was a week in Tahiti and 2 weeks in New Zealand. And the week in Tahiti was some sentimental family, not my side of the family, my wife's side of the family, but some sentimental reason. We got to go to Tahiti. I think their parents, because my sister-in-law was there too, I think their parents went there on their 45th wedding anniversary or something. So, okay, so we're going to Tahiti. But the only thing you can do in Tahiti is swim, sunbathe, or eat. There is nothing else in Tahiti. So if that's what you're going for, that's great. That's not where I was going. Astronomy, it's astronomy talk, right? So I got to concentrate on astronomy. That was me, went out every night. I got 1 hour observing, and it was always clear between 2 and 3 in the morning. The rest of the time was clouds. And New Zealand brags about how, oh, we have clear skies. They're beautiful. Well, not this trip. Okay, and then 2 weeks in New Zealand. And the reason for that is, and I'll pick on my sister-in-law, she is a Lord of the Rings fanatic. She wanted to see every location that they filmed anything from the Lord of the Rings. I said, okay, that's fine, as long as I get 3 days in the observatory. That was my piece. And I got that, which was a wonderful thing. All right, so again, you're planning. What are you going to take with you? So a planisphere is a must. That pink one on the screen is a Southern Hemisphere planisphere. And it's really cool, and it served me very well. So it's a great thing. Yeah, I know you can do all kinds of stuff on your phone, and that's wonderful. But I still like having something in my hand that at a moment's notice, I can dial it up and see what's up in the sky. Red flashlight, of course, that goes without saying. Recommend 10 by 50 binoculars. That's not what my pair looks like. That's a pair of Poro Prism, and mine are Roof Prism binoculars, but same thing. 10 by 50s are great. There's hundreds and hundreds of things that you can see, southern sky as well as up here. And a small telescope. And depending on what you're working on, if you're intending to pursue one of the certifications, therefore get a pin and a certificate and all that good stuff from the Astronomical League, some of them have to be done manually. And I'll warn you up front, there is nothing harder to do than try to drive a fully automated telescope manually. It's so counterintuitive. It just does not work. So it was tough. Once I get used to it, it wasn't too bad, but it was tough. And dress appropriately, drink plenty of water. And the reason for those last two is it was cold. It kept getting colder and colder. So we went in May, that would be fall for them. And it was kind of off season, so things were a little bit cheaper than they would have been if we'd been in high tourist season. But it also meant it was starting to get cold. In fact, on one of our excursions, it was the last one for the year. That day was the last one they were doing because it was getting too cold. Okay, let me keep going. So what happened? Well, we went to Tahiti. Tahiti is 16 degrees south. Perfect. The problem is, remember the whole thing about 1/3 of the sky is sunward? And so you can't see that on any given night. And as we go through the year, you see different parts of the sky. Well, with those two things in mind, you really want to go as far south as you can go, because that means more of it is circumpolar. More of it you'll see all through the night. So 16 degrees was great, not really far enough. And I mentioned the rest of those. Okay, then we went to New Zealand, and we managed to get down to 44 degrees south. So for us, that would be kind of the border between the US and Canada. That's pretty far. And that worked out really well. We were there. It was mostly clear at night. You know, during the day, we had a little bit of clouds, but the rest of the time it was perfectly clear. One night was so windy, I couldn't use the telescope. I'm sitting here looking through it visually, and I'm pretty forgiving when I'm looking through the telescope, but it was shaking from the wind so bad, I couldn't see anything. And so that night, I just turned around, went back inside and said, well, I'll get one good night's sleep. But it was absolutely awesome. So I recommend New Zealand very highly, is the bottom line of that. So what happened? Well, I did the Constellation Hunter, Southern Skies. That was pretty easy. It's constellations. Yeah, you have to hunt and pack and find stuff. You have to draw pictures, but it's not hard. Southern Sky Binocular, another fairly easy one, right? It's binoculars. Once you get used to them, it's so easy just to whip around the sky, say, okay, there's that star, that's what I'm looking for, and oh, right there is my object. So things are not real impressive, most of them anyway, in binoculars because they're small, right? If you've ever looked at Jupiter, yeah, you can see the 4 moons, but it's tiny. It still looks pretty good in a pair of binoculars. So a lot of deep space objects are kind of the same way. Orion Nebula. Yeah, you can see it in binoculars, you can see it naked eye, but it gets more impressive the bigger it is. Okay, Southern Skies Telescope. That was a little bit tougher, but again, it's not, those are easy objects. They're really bright and bold objects. Caldwell, much tougher. Those objects, I don't know why. I think maybe because I did most of them from the cities before we got to our final destination, that the skies were too lit up with light pollution and I just wasn't getting a good sky. And I was done by the time I got to the observatory, so that was kind of all that. Anyway, and as I mentioned, 9 left on the Bennett. Okay, so you got to go south. That's the moral behind this whole first half. There's so much to see. I didn't show you pictures. I mean, we could have done that, but then I would have run over and we wouldn't have gotten to Mod Pizza. So rather than that, I said, well, I'll just leave it. Of course, the internet is loaded with all these pictures and things. The lists are public, so you can go get them off the Astronomical League site, whether you remember or not. I don't know about y'all, but I happen to like lists. And the reason I like lists, and a picture here, right? I go up to our dark site, and if I go without anything planned, I'll look at all my favorites. I'll hit planets if they're out there. Probably not the moon, but I might. Yeah, it's light pollution, so I hate looking at the moon. It'll ruin my night vision. But I'll look at the planets. I'll hit the biggies. But I end up looking at the same stuff over and over again, which that's fun, but so the list gives me a group of objects that I may never have seen before and usually haven't. And so that gives me a chance to go look for something new and different. And that combined with other astronomers saying, hey, look at this, look what I just found. Gives me a long list of things that I haven't seen. So I get to see more. So I get to get closer to my goal, which is to see it all. That's my goal. So I'm going to get there. So I encourage you all, go south. Absolutely awesome. While I'm on the topic, because I will not bring it up again, but while I'm on the topic of the Astronomical League has challenges, and anybody in the world can participate in these challenges. And they're usually fairly short. We've got a couple of long ones in the barrel right now, but normally they're fairly short, as in you have a week to do it in and then a month to submit it. And you get certificates, you know, but you get a certificate emailed to you. So I encourage you to go after those. So a question came up earlier, what's up with T Corona Borealis? Well, we have an observing challenge for that. So if you are interested in participating, you should go get a look at it now, pre-nova, because you still have time. I had hoped by now I couldn't say that, but I can. So get a pre-nova estimate of how bright it is. And then what you want to do is come back after it goes nova and get a comparison. Photometric, you know, how bright is it? So that's one. Another one that we're in the middle of right now is the Solar Max Observing Challenge. It involves something a little out of the ordinary for all of you astronomers out there, because you need to build a magnetometer. And I have built 2 and had a workshop at the observatory where we built 10 more. It's made out of a soda bottle. Coke bottles are the best, by the way. Not that I own stock in Coke, but because they're shaped, they've got that narrow part down there, the waist. They're perfect for this. And about $10 worth of stuff. So compared to our telescopes, really dirt cheap. And it works. They're pretty cool. Mine, I hate to admit, has not worked particularly well, but it's running in an observatory with a steel roof, and it doesn't like the steel roof. So, and I've heard other issues, like when the garbage truck goes by, it goes nuts. You know, I've never seen that, but I've had other people tell me that. Anyway, so I want to just invite you to go take a look. They're under observe. You pick the alphabetical list, and then they're either Astronomical League challenges or NASA challenges. And the difference is Astronomical League challenges are object-based. So the Solar Max would be one of those. We also have one that will be coming up on the Parker Solar Probe. That'll be a NASA one, coming up in December for its closest approach to the sun.
Aaron,
Yes.
Is the magnetometer an astronomical league or a NASA one?
I don't know how to answer that question.
Well, where would we find it?
Instructions are on the Astronomical League website.
Okay, so that's where it is.
No doubt it's also on the NASA website. And the reason for my hesitation is one of the things that I do for the league is I liaison with a whole bunch of NASA-oriented groups. And we just did a webinar on making those
Okay,
last week.
but it's
So
on the astronomical league website.
yeah, it's on our site.
Okay.
And it's not hard. I mean, piece of cake. And if you have questions, send me an email. But anyway, so lots of those are out there. I encourage you to take advantage of them. I will give you a sneak preview. I'm not allowed to say details, but next year we're going to have a year-long challenge, which will be open to everybody, which is to commemorate and celebrate Hubble's 35th anniversary. It's going to be really cool. It is imaging oriented, but it'll still be pretty cool. Okay. Now, part 2. This is the really cool part. So, and at this point, I'm going to pause for a second and say I am impressed at whoever scheduled tonight, and I know it changed all over the place, but Paul Maley and I are perfectly aligned. I thought it was real funny. So the only thing I have related to the eclipse is I am wearing my eclipse t-shirt. But my talk, the rest of my talk, is about aurora. So let's go on. So part 2, aurora. So remember, northern or southern. And again, I'm going to go through the basics just in case anybody is not comfortable with them. But what happens is charged particles in the solar wind leave the sun. They come out here. Some of them hit Earth. And when they get to Earth, they get caught up in the Earth's gravitational field. And actually, that gravitational field is a good thing for us because it protects us from them coming in and hitting us, which is a good thing. And then they interact with elements in the Earth's atmosphere, most notably oxygen and nitrogen. And when they do that, we see colors. And I'm going to pick on Paul. He's not here to defend himself. He's not on, is he? I mean, if you remember his pictures, they were awesome pictures, by the way. If you recognize his pictures, there was a lot of green. Well, wait for it, because it can come in all different colors of the rainbow. All right, anyway, every 11 years, the sun goes through a sunspot cycle. And at that time, which we're in it right now, you hit solar maximum. That's the maximum number of sunspots. And the thing about those sunspots and other related phenomena is when the sun's in all this turmoil, it shoots off a lot more material into space. Things like coronal mass ejections become much more common. And we'll come back to that in a little bit. But those coronal mass ejections, if they happen to be pointed at Earth, send all of those charged particles at Earth. And they get caught up in our magnetic field. They go to the poles. They come flashing down through the atmosphere, and we get to see aurora, either northern lights or southern lights. So we are basically there now. We don't know exactly when the maximum is going to be. We should be there already, but the chart keeps going up and up and up. So I have a chart. It's a little dated, but I think it's in here. Anyway, we'll find out. Okay, a little bit on sunspots. There are disturbances in the magnetic fields on the sun's surface. So if you think Earth, right, we have north magnetic, south magnetic poles. Well, the sun's a little bit different because it's got north and south magnetic poles poking out all over the place, especially during maximums. So that's what those are. I mentioned that, skip that. Okay. And auroras are seen around the Earth's magnetic poles. And so normally, there are places like Churchill, as was mentioned in the previous talk, that they can see, I think they brag about seeing aurora 300 out of 365 days a year. That's pretty impressive. So well worth the trip, especially during a maximum. And they come in every color of the rainbow. So the most common ones are red and green, but we'll continue that discussion. All right, so what happens? Well, I mentioned it's an 11-year cycle. It's actually a 22-year cycle. However, what matters to us, the casual amateur observer, is every 11 years we hit a maximum. What happens is the poles switch every 11 years. So the first 11 years, the north spots come first. The second 11 years, the south spots come first because sunspots come in pairs. Big deal. That doesn't affect my observing, but it's kind of a neat thing. So there are more. There are larger ones when you hit a maximum. So we're there now. And I mentioned the coronal mass ejection, so I can kind of skip that too. They don't all head for Earth, right? The sun's a ball, so the charged particles come off in all directions. But if a sunspot's on our side of the sun and at kind of the right position, by the time it turns a little bit more, that emission is going to nail the Earth. And so we get to see something. Okay. Enough said on that one. Let's go on to the next one. So the colors do mean different things. Like I said, red and green are the two most common. Red, high levels. So very high up there in the amount of solar activity. So if you're going to see red ones, solar max is the time to do it. Above 150, and it says up. It's miles, by the way. I don't know why I left that off. So above 150 miles up in the atmosphere. So very high in the atmosphere as well. And the main cause there is oxygen. I'm going to skip over to the green one because I want to hit the common ones first. So green are most common, 60 to 150 miles up, and also with oxygen. So, we get a lot of oxygen in our atmosphere. They're at 21%, so quite a bit, and lots to interact with. But then you also have things like the blue and purples. And those are, again, only visible during high levels of solar activity. These are 60 miles high or less, so they're not that high in the atmosphere. And now the charged particles are interacting with nitrogen. So different chemical, you end up with different colors. And then there also can be yellows and pinks. And again, back to high levels of activity. And really all this is combinations of red and green or blue. Because we all know if you mix those colors together optically, you get the other colors. So, right, that's how your computer screen works. Okay, so it is possible to see all of these colors, and there are little arrows there pointing at them. Odd coloring up there, but okay, it's even worse on the computer up here. All right, so what happens here on Earth? Well, if you're looking north for the northern lights or south southern lights, could be either way. Some things, horrible things can happen. We've had power failures, massive power failures. And what happens is sometimes these charged particles are hitting us so strong that they burst through the magnetic fields, they go through the atmosphere, they reach down to Earth, and they can short out our electrical utility systems. Because they're charged, right? So they have a charge. Big deal, big deal. It's also a problem for spacecraft in orbit. So if you are lucky enough, I guess, to be one of the astronauts up there in the space station, I guess that's not true for a couple of them, but the rest of them are lucky. I'm sorry, that was kind of political. But all right, anyway, when one of these is coming towards the Earth, so right now there are a bunch that head towards us, they have to seek a place of refuge in the station. Typically, it's one of the spacecraft. And the reason for that is those capsules, and Soyuz capsules especially, are really heavy duty, right? They go through a lot of stress, so they got to be heavy duty. And so they give them more protection than the space station, which is, in my opinion, rather flimsy. Okay, so it's dangerous to those folks. And if you think about going to the moon or Mars, it's even worse. Because there, you don't have the protection of the Van Allen radiation belts, right? Those are Earth things. And so right now, we've got a couple astronauts that are actually up there outside of the Van Allen radiation belts. And that's kind of cool because, doing things that people haven't done before, but still risky. Anyway, all right, moving on. This is what the pictures look like if you are trying to say, should I go outside tonight and look north? So if you take a look, the one on the left there is for northern hemisphere. The one on the right is for southern. And if you think about where we were in New Zealand, we were about where that red spot is. And it was close, but we would probably have not seen this one. Might have been very low on the horizon. And I can't point out where Churchill is. But if you're in the US, I'll go here, you're definitely not going to see that one in mainland US. Alaska, better, right? If you're up here in Fairbanks, you're pretty close. You might be able to see it. So where you are is very important. The strength is very important. Now, these are projections. This is what they're recommending is likely to happen. So the idea is you look at this and you decide you're going to go out tonight to look for aurora. And that's a wonderful thing. If you want to know where this is, there's lots of places on the internet you can get them. These are off of a website called spaceweather.com. Spaceweather.com. It's all one word. And it also has an image of what the sun with sunspots looks like today. So you can get all that information. Plus, if you're going to do a magnetometer, it has information on the K index as well. The planetary K index, which is what your magnetometer should be showing you, actually. They're very closely related. Okay, so the green is the auroral ova. Let's try that again. Oval, auroral, I can't say it. Auroral oval. And it changes. I was looking at the site, and from hour to hour, their projections are changing. Because, you know, they say, there's a lot more happening in the atmosphere. We're going to up it a little. So green is mild. It goes all the way up to red, which is intense. Red is very intense. Okay. And what do these look like? I don't have to show you these because Paul did his. But they come in different shapes. So the one at the top there are draperies. That's what a lot of his were. Those, in my opinion, are the really coolest ones because you can actually see them move in real time. And they fluctuate, and it's wonderful. There are arcs, diffuse ones. This is the arc over here. This would be a diffuse, I think. Rays and coronas. And so I'm probably pointing out the wrong ones. Just bear with me. Lots of different ways they can manifest themselves. So lots of different things to look for. Okay, so I do have some warnings, though. They're not dangerous, by the way. So not that kind of warning. But they do come and go. So they could be there 1 minute and gone the next. And that's especially true not during the peaks. So if you look at that K index that I mentioned, it shows you it's bubbling along at green, nothing much to look at. And then maybe it goes up to yellow for a few hours, but then it's back down to the green again. Well, if you're not out there for those 3 hours, you're not going to see the really profound aurora. So you do have to be persistent and patient. I took a trip up to Alaska. This was not during the peak. And we went all the way to Fairbanks. And on that entire trip, not one bit of aurora. And the whole time I was in Fairbanks, it was cloudy. So, you know, you're patient and persistent. Okay. They may be too faint for the eye, for your eyes to actually see them, color. So you do know in your eyes, you've got color sensors. They're not nearly as sensitive as black and white. So when you look at them, you'll see them and they may look black and white to you, but in reality, they're color. So that's when you whip out your camera, even your cell phone, take a picture of it and the colors will just bloom. It's absolutely wonderful. Okay. So light pollution, absolutely the death knell for this. So if you want to look at aurora, you definitely want to be in the blackest skies you can find. And of course, weather is the wild card, per my going to Alaska example. Okay, so I mentioned we measure the Earth's magnetic field using something called a planetary K index. They can actually, it actually has a name. I had forgotten it had a real name. Anyway, that's useful, but what it's most useful for me is telling me when were the peaks, when were the not so peaks. The measures on that scale go from 0 to 9, 9 being the strongest. Actually, the highest one is called 9+. So that means you went right off the top of the scale. They're dark red on that chart. And it's a weighted average from 13 different ground stations over 3 hours. So when you look at that chart, it'll show you 3-hour blocks. And that doesn't tell you a whole lot either, because the peak could have been 10 minutes long, somewhere in that 3 hours. So a little bit of a challenge. All right, so here's the scale and what they think it means. So normally we're down there very low, under 5. Once in a while we get lucky and it goes up to 5, sometimes 6, sometimes 7. And the only time we're likely to ever see them here is if it hits 9+. So it happened, must have been 11 years ago, might have been 22 years ago. And it happened earlier this year on May 11th. But I understand it was cloudy here. So I was glad I wasn't here because I wouldn't have seen it. But that's what it takes to get this far south. We're a long ways from where they normally are. Okay, so I wonder if that's a video. We're going to try it and see what it does. Let's watch the video first, and we'll come back and talk about it. So I was in New Zealand on May 10th, which is on the other side of the date line from here. So actually it was May 11th here. And this is what this solar, I can't think of what it's called. So Justin, what's that picture called? The blue one.
You mean for the spacecraft?
Well, no, just the name of that. Is it a solograph?
Yeah, it's a chronograph.
Coronagraph. Thank you. That was the word I was looking for. I knew you'd know. I just couldn't remember. This is the coronagraph at that time. So let's see what it does.
That's the Soho chronograph.
Yeah. So every one of those things that you see going off in a cloud spreading out from the center, the sun is behind the center. Where'd it go? The sun is behind the center. And, well, that's interesting. Okay, I just like to look at it. Every one of those puffs that look like smoke are coronal mass ejections. Okay, so there were a bunch of them on May 10th/11th. The sun looks like that picture on the left there, and you notice there's this huge sunspot group. I'm pretty confident that had to have a lot to do with what went on. You know, it had already moved off center from the sun. So if you imagine the center is pointing straight at us, so if it shoots at us while it's looking straight at us, it takes 2.5 really, to 6 days for it to get here. The light gets here in 8 minutes, but to get the charged particles here, it takes a few days. And in that time, the sun has rotated, and so that spot has moved off to what I would consider to be the west. Okay, so that was what was going on sun-wise. And you remember those pictures? Well, here's what they looked like when I happened to capture them. And you'll notice the one on the right, again, I was in New Zealand, right? So what you notice over here with the US one is in this image, it's coming halfway down to us, maybe more in the US. It's bright red, which means it's a very, very strong one. And if you look at this one, the problem with this is I was there at night. This image was created, or it's a forecast, so it was created during the day, right? Up here, New Zealand's in daylight. So by the time the Earth rotated, New Zealand was right in the middle of this. All right, that was a little teaser there, right? Okay, so pretty impressive. So more data on what was happening. New Zealand is 12 hours out from coordinated universal time. So these charts are completely backwards. If you look at 12 a.m. on here, it's 12 p.m. there, because these are universal time. Okay, so what happened? That's the week before, the week of, and the week after. And what I notice is right here, this first day of this week, which ought to be, I don't know what day it was, Sunday or Monday, whatever day it happened to be, it went 9+. That was one of the big ones. And 3 days later, it went 9+ again. In fact, it's red the whole week. I mean, this was just incredible. Now, what happened on the sun? So you watch the coronagraph, and on the coronagraph, you probably didn't count them. And depending on who you ask, you'll get a different number. My wife says it was 4. I say it's 5. And NASA says it was 9 coronal mass ejections. So we'll go with a 9 because that's really impressive. So what happened? Well, when they leave the sun, they come to the Earth, and depending on how big the ejection is, sometimes they go faster, sometimes they go slower. And what happened with those 9 is they collided with each other, stacked up, and then hit the Earth. That's what was going on that week. It was totally nuts. Okay, so the maximum on that day was 3 a.m. New Zealand time. And I've got it wrong. Oh, that's the first one. Skip that one. Because that's a daylight one, and I wasn't up at 3 in the morning. The second one, though, was from 3 p.m. until about midnight. That's not what it says there. It says 9 p.m. Oh, because that's no matter. Evening. 9 months ahead of time, we scheduled a night at the observatory. We signed up for a star party. And I was thinking, all right, I've been out 2.5 weeks in the Southern Hemisphere. I probably could do the star party. But we'll go ahead and listen to what he has to say. So the family and I went off to the observatory. Again, schedule it 9 months ahead of time, so you can't predict these things. We get there, and we are at the observatory. It was just the 4 of us and 2 astronomers. And we were there at the peak of the best aurora we've seen in 500 years. So, yeah, no offense to y'all, but I'm glad I was down there because that would have been daylight here, and that would not have been any good. Okay, well, anyway, so that's where we were. That's what we were seeing, and it absolutely was incredible. It's coming. Wait for it. Wait for it. Where were we? Okay, we were at a place called the Mount Cook Lakeside Retreat. It was on Lake Pukaki in New Zealand, and it's in the middle of an international dark sky preserve. So that whole purple piece there is the dark sky reserve. We're right next to Mount Cook. Absolutely beautiful environment. Our little lodge was out looking over a lake at Mount Cook. I mean, it's just absolutely incredible. So it was wonderful, really, really dark. They have a 9.25 inch Celestron SCT. I will also tell you a secret there in just a moment. But anyway, and it was not supposed to have been a private star party, but we're the only people at the resort that signed up for it. So it was 4 astronomers and the 2 astronomers and the 4 of us. And the sad thing was, I don't know if it was sad or not. The sad thing was the aurora was so profound and so bright, we couldn't see the stars. We grabbed our chairs, went out into the field next door, and sat and just watched the aurora. And it was amazing, absolutely amazing. The other thing I need to mention is the observatory that I run up in Humble is part of a school district. So I can't do this with theirs. But at this one, their observatory was attached to their wine cellar. And we walked in the door, and the first thing the astronomer said was, red or white? And if you said, nah, I'm not into wine, he'd say, well, we also have whiskey, if you're into that. And like I said earlier, it was 32 degrees. He said, and we have hot chocolate. And I think we drank them out of hot chocolate because it was freezing cold. But if I ever build my own observatory somewhere, it's going to be connected to my wine cellar. That's the way to go. Okay, so we went to the star party. And this is a picture I took. So I actually did get my aurora picture in here. No detail like we saw in Paul's pictures. And that's because it was everywhere. Literally, when we got there, we had pillars of light coming up from every horizon, all 360. And they were meeting overhead because we were right in the middle of that oval. Okay, so our star party started at 8:30. It ended at 10:30. It was only supposed to be an hour. But we stayed. The skies were absolutely crystal clear and, of course, dark. 32 degrees, I mentioned that. And I just mentioned that when I stole my own thunder there. But it was absolutely amazing. And as my little red note down there says, it was all pure dumb luck. I just, sometimes the stars align for you. And when they do, you need to be there to take advantage of it. Okay, so this next thing I'm going to show you is not something I did. I hate to admit it. It was done by one of the astronomers. It's one frame. It's going to be a movie. One frame every 5 seconds. And he did it while we were at the observatory. So it is what we were seeing. I was just too flabbergasted to do anything other than snap a few shots myself. So here we go. Are you ready? So we got purples. I mean, just everything. And that's it. So yeah, it ruined my plans. I had besides that night, no, seriously, my life plans. I had 5 or 6 trips planned on where I could go to see Northern Lights. And it included Churchill. That was one of them. Iceland's on the list, Norway. I've been to Fairbanks, Alaska, so that was not high on my list at this point. Hold on, it's talking to me. Battery, I can just close that then. Okay, and there's no need to do all of those anymore because the reality is 9 coronal mass ejections, that'll never happen again, not in my lifetime. So, hey, I've seen it. So now I have to pick places I want to go to because I want to go there as opposed to astronomy, but that's all right. All right, so a little bit of wisdom from a crazy old amateur astronomer. Obviously, we're getting close to the end. Observe, observe, observe. Let me say that again. Observe. You want to get out there. That's what it's all about. I mean, these presentations are fun. The meetings are fun, and we get to talk to friends and learn all kinds of cool stuff, but it's all about observing. So get out there. And I said this before, I'm going to say it again. There are those rare moments in your life when the stars perfectly align. If you're in the right place at the right time, you will have a chance to experience some of them firsthand. And I figure by my count, this has only happened to me twice. And as was mentioned, I've been doing this for 45 years. That's a long time between events. And then my snide little comment here. If you're busy watching TV or surfing the internet, then you will miss them. So I do want to encourage you all to get out there. I want to encourage you all to go south of the border. And these are the two. The other one was a Leonid meteor storm in November of 2002. We knew it was going to be a good one. I was up at the NHAC dark site. Again, the first one, not the one we currently use. And at the peak, we estimated, you couldn't count them, we estimated 1,435 meteors per hour during a 15-minute peak. They were everywhere. And I don't have time tonight, but there are also some cute stories that went along with that because I experienced some stuff I'd never experienced before. But anyway, and that's it. Any questions that I might keep them simple? At the back.
So the movie you showed, was that the full 2 hours of the star party or how long?
Well, I never actually timed it, but yes, it would be close to the 2 hours. All I know is he took one frame every 5 seconds.
That would be like 720 frames an hour.
Yeah, so I don't really know.
Okay.
And I would have to translate that. All right, so if it's one frame every 5 seconds and you're running at 30 frames per second, which is the movie rate, I don't know. I can't do that math. It's too late at night and I haven't had my pizza yet. But yeah, I mean, he set it up when we started and took it down when we were done. So I'm assuming it was all 2 hours. But it was really cool. They were wonderful. Oh, 2 just quick things. Hold that thought. 2 quick things. It was expensive. Now, the trip was expensive too, because it is, right? Because you're going a long way. But the resort we stayed at, I swear, the person who made those arrangements sent us first class because it seemed ridiculously expensive to me. However, it was worth it because everything worked out really, really well. The other thing I forgot what it was. It'll come back to me. Yes?
Is there any study that from the aurora people could get some information about the composition of coronal mass? I mean, mass ejected mass. Like what is it made up of? Or composed of?
Well, I can answer the question. Well, I can answer the last part of the question. There's no question that it's roughly 90% hydrogen, 10% helium, because that's what the sun's atmosphere is. So if it's shooting it out, that's what's coming our way. Now, in reality, what is it by the time it gets here? It's charged particles. So it's electrons and I was going to say protons, but it may also be helium nuclei. So, some combination of that stuff. And there'll be other trace elements, because obviously there's trace elements up there too. But, that's largely what it is. We know it's the charged particles because if they weren't charged, they wouldn't interact with our magnetic field. So, but the colors are related to what it's hitting in our atmosphere. Again, oxygen or nitrogen for the most part. And so I don't know the answer to your first part of the question. I'm going to dodge it. Yes.
Since you brought up the colors, you said red if it's very high, and that's oxygen, and green if it's low. Is that the difference between atomic oxygen and molecular oxygen?
I don't know the answer to that.
So is that at 150, what did you say, 150 miles up?
Yeah, that's way up.
Yeah, I don't think there's much molecular oxygen up that high. I think it's mostly atomic oxygen, right?
Yeah, so that makes sense. I just don't know the real answer, and hadn't thought about it. So something to go home and look up. Yes, sir.
Talking about the 9+ that have happened and everything, I had read that, I think it was 1848, they had one that occurred, and the reason they knew it was because all the telegraph that was going on, when it occurred, they told them to disconnect their batteries, and it was still working. So has there been anything, like that recently?
I haven't heard anything from this one, so the one in May. And theoretically, we're smarter, right? Or should be.
The article didn't say anything about us being smarter. It was more like we're not smarter. So.
Well, and we probably aren't, but we should be. I do know we've had major power outages in the past. So that would have been 11, 22, 33 years ago. I'm not sure exactly when, because I don't remember them in detail. I wasn't an astronomer or a serious astronomer.
Would that have been like a 9 or 10 or 12 or something that's way off the scale, do you think?
Well, they don't go above 9+, but yes, it would be really intense because it should get caught up in the magnetic field. And if it doesn't, that means it's got to be really powerful because it made it through it. The K index is just an indication of what's happening with the magnetic field in the Earth's atmosphere. So in theory, it's going to be different here than it would be up north. But I figure, it still shows the same intensities. It's going to get heavier and then lighter. But yes, it would be extremely intense. And I don't know if this one that just happened in May qualifies or not. Yes, sir.
Can something like volcanic activity, large volcanic activity, throwing things in the atmosphere affect the way you might see aurora borealis or aurora?
They're different phenomena,
Well, I'm just saying,
obviously.
Interacting with other particles like that.
So I'm a little out of my league. I'm not a volcanologist, so I will make a guess for you, but I don't know the real answer. Normally, I would expect volcanic ash and things or gases that it's putting in the atmosphere to be at lower levels than at least the red auroras. And the auroras are not caused by interacting with physical particles as much as they are elements, the atoms themselves, be it binary or just single atoms. So I would not expect a major impact or interaction. And I could be completely off, but that's my take on it. Anybody else? Yes, sir.
So you mentioned earlier,
trouble with binocular, some people said that when you look at this, so what's your trouble with telescope?
Now that I've gotten all of my, well, I've got to do 7 more Bennett's, or 9 more Bennett's. But aside from that, now that I've done most of the observing I need to do, I'm switching, and my preference at this point is a C-star. I've been using manual telescopes all my life, and so I've paid my dues. And I've earned it. So, my attitude is, less work. Still have to do all the planning, but as far as execution is concerned, much, much easier. I do not recommend that for people who are just starting out. So any of you that are new, you need to learn the sky. And you won't do that with a telescope that does everything for you. But I've always been a proponent of go-to telescopes. My first telescope was a go-to. If I was going to take a more conventional telescope, I have a Meade ETX 125. So it's a little 5-inch telescope. I love it. Not happy with Meade, but I love the telescope. So that's what I would take if I were going conventional. And there's lots of good telescopes out there. But again, it's a go-to. So, I don't have to search for stuff. And like in this case, doing 250 in essentially 2 weeks, I didn't have time to spend doing a whole lot of searching.
Yeah, I go to it, such a lot. These are small ones.
Yeah, so what I did on this one was I stretched the rules a little bit. I used the telescope's go-to functionality to get to a bright star. And my thinking was, I can get to the bright star. That's a no-brainer. And then I would star hop from there. So, I shouldn't admit that in public. Yes?
Will the ETX 125 work in the southern hemisphere?
Yes. Yep. There is a switch. I got to think about this. There's a switch you have to